Okay, year 8. Let's move on to something that doesn't have straight sides, or indeed, if you're like me, like to think of it as an infinite amount of straight sides, the circle. Now, when we talk about circles, we need to know a few things, and we need to know what certain things are. So what you need to do is you need to pause the video and you need to draw this, and you need to write some of these things here. And that will help you because that's going to be the answer to question 3. Okay, so hopefully you've done that. We come back here, and the circumference of a circle is just a word we use to describe the distance around the outside. So the distance around the outside of a circle we're going to refer to as the circumference. Now, this is hard to measure because a circle has no straight sides. So how do we come at finding the circumference of this circle? Well, I'm going to take you on a little journey. Here's a square. Now, we know in a square that all the sides are right angles. All the corners are made at right angles. So what do we have with this square? Well, we can work out the perimeter if we've got the side length. So let's say I gave this a side length of 5, and I can work out the perimeter. The perimeter equals 5 plus 5 plus 5 plus 5, which is 20. But what if I wanted to find the distance of that? Well, luckily we've done Pythagoras, and we'll call that x, and x squared equals 5 squared plus 5 squared, which equals 50. That's what x squared equals. So x equals the square root of 50. So let me have a go at this. The perimeter over x, which is the diagonal. Well, let's have a look at what that is. 20 divided by the square root of 50. 2.828. 2.828 and a whole lot of other numbers. But let's say we didn't use 5. We used a different side length. I don't know. Let's use 1. So if that's 1 and that's 1, does it change everything? Well, let's see. The perimeter is 1 plus 1 plus 1 plus 1, which is 4. And this distance, the diagonal, is 1 squared plus 1 squared, which is 2. So x in this other square is 2. Well, the perimeter of the square over its diagonal is 4 over root 2. Well, let's see what that is. 4 divided by root 2. Oh, 2.828. It's exactly the same. And there's a reason for it. All squares are bigger or smaller versions of the same shape. They are similar shapes. It doesn't matter how big or small a square, they are the same shape. They're just bigger or smaller versions. They've been enlarged or they've been shrunk. It doesn't matter. And as a consequence, all the ratios of lengths and sides are going to be the same, no matter what. So the perimeter to the diagonal of any square, the perimeter to the diagonal will always be 2.828. So why am I wasting my time telling you that? Because you know how to do that. But for a circle, it requires a little bit more. All circles are also similar. They are all smaller or larger versions of a circle. It doesn't matter what you do, all the dimensions of a circle will be in ratio. And what are we trying to find? Well, we're trying to find the circumference of a circle. And we know that for all circles, the circumference over this line here, which is the diameter, will equal a set number. It doesn't matter what it is. And if I can find that number out, I can work out the circumference of any circle. So how can I do that? Well, if I draw a circle, and this is how Archimedes did it, and we're going to talk about him in a minute. Archimedes went, righto, I can't calculate this circle, so I'm going to draw a triangle in there, and I know that the perimeter of the triangle will be less than the perimeter of the circle. But then and that's an equilateral triangle, if I cut that triangle into every side into two parts, I'll get a hexagon. And every single one, the perimeter of the hexagon will still be less than the perimeter of the circle. Now, if I then cut each of those sides in two, and I'll get a dodecagon. And each one of those sides is the same. I can calculate the perimeter of that, and that'll be less than the circle. Archimedes, so you can see there it's pretty hard. If I go another step, it's even harder. If I cut all that, that'll get me 2 times 12, 24 sides. And Archimedes didn't stop at 24. He went to 48, and then he went to 96. He drew a 96-sided polygon inside a circle. And then he knew that the polygon would have a perimeter slightly less than that of the circle. But then he went even further. He drew a triangle, equilateral triangle, outside. He cut each of these in two, and he got himself a hexagon. Hold on, have I done this right? Made that two? I think I've done that wrong. I think he might have even started with a hexagon. So if I start a hexagon outside the circle, so and then you cut those sides in two, and you get closer and closer again, and you'll find that you get a polygon inside and outside the circle. And from that, he was able to determine a value of pi. Now, lots of other civilizations have given us values of pi. We had the Egyptians, they knew a value of pi. The Babylonians, the Indians, but Archimedes was the one who was able to inscribe a polygon inside and outside, and hence show that the value of pi was greater than 223 over 71 and less than 22 over 7. And that is what was most commonly used to find the circumference of any circle, or indeed later on the area. It is worthwhile noting that the Chinese gave us this approximation, which is more accurate. So, accordingly, he called this ratio pi. So if C, the circumference over the diameter, equals this number pi, which is 3.14 ... I can find the circumference if I just multiply that d across, and I'll go circumference is pi times d. This is like an equation. I multiply the d across, and hence I get my formula for the circumference of a circle. It's pi, which is a number, 3.14, times the diameter. So When you come down here, you should have already done question 3, because if you did your notes, all right, let's have a look at question 1. Now I want you to be able to use your calculator. So question 1 says evaluate using a calculator, and it's pi times 5. Well, pi on your calculator is located down below the 3 button. It's one button below the 3, but it's in yellow. So to get to it, you have to press Shift and that button, up comes pi, and then you just do your calculation, times 5. 15.707. 15.707, and there are a whole lot of other numbers after that, but we're rounding to 2 decimal places. So we draw a line 2 decimal places in, we write 15.7, we look at the number directly behind the red line, and if it's 5 or more, we round the number up. We make the number in front of it bigger by 1. So 15.71. You do B and C, and then also have a go at D. I'm going to have a go at D. 2 times pi times 37. Bang, straight to my calculator. 2 times Shift down here times 37. 232.477. 232.477. There are a whole lot of numbers after that, but I'm not concerned about them because I'm stopping there. So 232.4, look at the number behind the red line. Is it 5 or more? Yes, it is. So I'll round that to 8. Righto. Let's have a look, because you've done question 3, and a couple from 5. I'm only going to do 5, C and F. You do the rest. 5C. Okay. What's our formula for circumference? Pi times the diameter. Well, pi, it's in the calculator. Over here, they haven't given me the diameter. They've given me the radius. They've given me 39. So if the radius is 39, the diameter equals 2 times 39. And I'll go to my calculator. $78. So the circumference is pi times 78. And again, on my calculator, Shift pi times 78. Too many. And 245. 245 point, what was it? 044. There were other numbers there, but again, I'm going to 2 decimal places. I look there, 245.0. Is the number behind the red line 5 or more? No, so I leave that alone. And it was in centimetres. Now 5F, circumference equals pi times D. This time they've given me the diameter, so it's even easier. So just go pi times 5. $15.707. 15.707. Again, I'm going to round to 2 decimal places. So I'm going to go 15.7 is the number behind the red line. 5 or more? Yes, it is. 1, and that was in centimetres. Okay, you should be okay. You should have done 3. You should have done B and C from 3B. You should be able to do the rest of 5 on your own. Good luck.